Welcome back, and at the bottom of the page here you can see that my answer from the previous slide would have been 9x minus 2y times 9x plus 2y. So let's move on to the idea of perfect square trinomial. And what a perfect square trinomial is a polynomial that has three terms that always factors into two factors that are exactly the same, two binomial factors with the same number. So what does that mean for us? Well, if you think about it, when we say a plus b squared, remember what that really means is that we're talking about the quantity a plus b times itself. And if you were to use your FOIL method, you should come up with an expression like the one up here at left. So how do we know when we've got this situation? Well, one big tip-off for us is that whenever you have a perfect square trinomial, it factors into terms that include the square of the first term and the square of the last term. And both of our outer and inner terms, when multiplied, would be exactly the same. So it would be the product of the two inner terms, the two terms, a and b, times 2. Right? So if you think about it, if we take the square root of the first term, we take the square root of the last term, there are two of them here. And so it's a good way to remember that this would be our factorization. Now here's a good example, a really basic one. You'll note that the first term, of course, is a perfect square, and so is the last term, right? And if we note that that is the case, that might be a tip-off that our middle term would be twice the square root of either end term. Well, let's take a look. We've got x being squared here as our first term. We've got 25, which is the square of 5, as our last term. And just like it looks, if we take 2 times 5 times x, well, yeah, that is 10x, and that looks like our first factorization form up there. So we can say that this factorization is exactly the same as x plus 5 times x plus 5, or just simply stated, x plus 5 quantity squared. Well, how about this one down here? We've got x squared minus 6x plus 9. Well, again, this is the same deal, and our tip-off right here is that 9 is the square of 3. So if we use that, we can use this second form right here, and it looks as if we take the square root of the first term minus, because of our negative term right here for our middle term, the square root of the last term. Then we could say x minus 3 times x minus 3, but it's more convenient to simply state it as x minus 3 squared. And this is considered the factored form. Now, as you know, you should be able to check all of these things. And if you were to check by multiplication, you would certainly see that if we took x minus 3 and multiplied it by itself, by the FOIL method, we'd be getting the square of x, negative 3x as our outer terms, negative 3x as our middle term, and plus 9 is our end term. And since there are two negative 3x's, we multiply that by 2, and we get x squared minus 6x plus 9 as the factored form of this thing, or as the unfactored form of this anyways in our check. So x minus 3 squared. What if it gets more complicated, Professor Peebles? What do I do with that? Well, let's take a look at this guy. We've got 25x squared plus 30x plus 9. The thing that you need to key in on is if you have a special form like this, we know it's a special form if the very first term is a perfect square, and of course this is a perfect square of the quantity 5x. And the last term is a perfect square, which is the square of 3. And if we take 3 times 5x and multiply that result by 2, well, sure enough, that's our middle term, 30x. So this should factor as 5x positive from our 30x, so we take the plus from that, and then the square root of our last term, which would be 3 squared, and this would be our factorization. So now you probably look at that last one going, well, 3x squared isn't a perfect square, neither is 27. What do I do with that? Well, the very first thing you should note is that each of these terms has a common factor, and before you start any kind of factorization, you should always make a habit of factoring out the GCF, the greatest common factor from each of these terms. And in this case, that happens to be 3. And if we take 3 and factor it from 3x squared minus 18x plus 27, we get x squared. We would have to take 3 times negative 6x to get negative 18x. And we'd have to get 3 times 9 to get 27. And we've just factored that guy at left, right? So we've actually got 3 times the quantity x minus 3 times x minus 3, or simply 3 times x minus 3 squared. So that's our factorization using a perfect square trinomial. More in the next video.